Hello students, welcome back to Art Math Genesis. In today's session, we will be discussing some of the concepts which we will be using to solve the problems for exercise 1.2. Alright, okay, today's first concept is representation on a number line. Okay, we all know a number line. Okay, when you want to represent on a number line, any number will be represented just as well. Suppose if I want to represent number 2 on a number line. So, if it is natural numbers, then they start from 1. Okay, the number line starts from 1, 2, 3 and so on. It means one side of the number line is fixed and the other side is towards the right side is indefinite. Means you can continue, it's infinite. Alright, so for natural numbers, okay, on a number line, it starts from 1, wherein one side is fixed and the other side is infinite. Alright, next, when we see the whole numbers, for whole numbers, the number line starts from 0, 0, 1, 2, 3 and so on. It means here also one side it is fixed and the other side is infinite. Okay, next comes the integers. Okay, for integers, okay, on a number line, in order to represent any integer on a number line, it will be extended indefinitely both the side. Alright, towards the right side as well as towards the left side. Okay, so this is our point 0, 1, 2, 3, so on towards the right side. Similarly, negative numbers, -1, -2, -3 and so on. So, it is extended indefinitely towards both the sides. Next, representation of a rational number. Okay, now for rational number, if you take a number line, to represent any rational number on a number line, rational number will have what? It will be having a numerator as well as the denominator. So this representation is little different compared to the other number system in the number system. Okay, for example, if we want to represent some number on a number line, for example, if you want to represent 1/3 on a number line, so if we take this as our number line, okay, in our number line we have negative numbers as well as the positive numbers. So randomly I am just marking the points. Okay, now we have to represent this on a number line. If you see that of all these numbers, we have a numerator as well as the denominator in rational numbers, right? So when we have numerator as well as denominators, to represent a rational number on a number line, we need to check for two conditions. What is the first condition? If numerator is less than the denominator, then that rational number will lie between 0 and 1. Okay, if the numerator is less than the denominator, that rational number lies between 0 and 1. Second one, if the numerator is greater than the denominator, we have to convert the rational number into a mixed fraction and we have to represent it on a number line. Okay, now suppose, now what is our example? It is 1/3. If you see our 1/3, our numerator is less than denominator. Okay, that's the first case. So our mark or the point lies between 0 and 1. Next, in the denominator, you see what's the number we have? 3. It means here denominator is 3, means we have to divide into 3 equal parts. Here, suppose Here now between 0 to 1 means we have to divide into how many equal parts? 3 equal parts. That is 1, 2 and 3. So now this will be 1 by 3, 2 by 3 and this will be 3 by 3. So our answer 1 by 3 will be here. Okay, now this way we will be representing on a number line. Alright, now we will take another example. How to represent on a number line using if numerator is greater than the denominator. For example, if you take number as 7 by 4. Here what we can see? Here numerator is greater than denominator. So if numerator is greater than denominator, we have to convert that into a mixed fraction. So 7 divided by 4, you get 4 ones 4. Here it is 3. So how we can represent that in a mixed fraction? 7 by 4 we can represent as 1 3 by 4. Okay, so here if you consider the 1, okay, this part means our number line, the point is 7 by 4 lies between 1 and after 1 and another natural number is 2. So our point, this 7 by 4 rational number lies between 1 and 2. Now, okay, now if we take a number line, so this is 1, 0, 1, 2. Alright, now I said 1. So our number line lies between, or the rational number lies between 1 and 2. Now next is 3 by 4. I said for 3 by 4 we have to see the denominator, means how many equal parts we have to divide? We have to divide into 4 equal parts. So we'll 1, 2, 3, 4, 1, 2, 3, 4. So we have been divided each one into 4 equal parts. Okay, now our rational number is 1, 3 by 4. So it lies after 1. 3 by 4 means what will this will be? This will be 1 by 4, 2 by 4, 3 by 4 and this will be 4 by 4. So our answer is this 3 by 4, which is 1, 3 by 4, or it is 7 by 4. So this way we will be representing our rational numbers on a number line. Alright, we have to check, first thing is if numerator is greater than the denominator. If numerator is greater than the denominator, we have to convert into a mixed fraction and we have to see the first term, first letter or the first numerical, and our point lies between that number and the next consecutive number. Alright, next this is about the number line, representation of a rational number on a number line. Okay, next comes the concept of rational numbers between two rational numbers. Okay, but now if you want to represent any number, if I want to represent numbers between 3 and 7. What are the numbers between 3 and 7? We'll write as 4, 5, 6. These are the numbers between 3 and 7. Okay. Suppose if I want the numbers between 1 by 5 and 1 by 10. Numbers between. So what we'll be writing? 1 by 6, 1 by 7, 1 by 8, 1 by 9. These are the numbers between these two, or these are the rational numbers between these two rational numbers. Okay. Now, are only these numbers are present between these two rational numbers? Suppose the same number 1 by 5 I can write as 10 by 50 and 1 by 10 as 10 by 100. So now, how many rational numbers will be there between these two? We'll get 11 by 50, 12 by 50, 9 by 100. So we get and we can make further, like if it is 100 by 500 and in between 100 by 1000, so it will be like 101 by 500, 102 by 500, and so on up to 99 by 1000, which means that between any two rational numbers there are definite rational numbers. Rational numbers, between two rational numbers we have two methods. Okay, to represent there are two methods. First one is using the denominator method, and second one is using the mean method. Okay, well, if we want to find rational numbers between 1 by 4 and 1 by 2, any rational number between 1 by 4 and 1 by 2, so we'll be using method 1. Okay, what does a method 1 says? Method 1 says denominator method, means we have to make sure that these both denominators are equal. Okay, so 1 by 4 I'll multiply with 2 so that I'll get 2 by 8. Similarly, this 1 by 2 I'll multiply with 4, so what will get? 4 by 8. Now in between 2 by 8, 4 by 8, what is the rational number we have? 3 by 8. So 3 by 8 is the rational number between 2 by 8 and 4 by 8. So this is our answer. So what we'll do, we have to convert the denominators, we have to change the value of denominators to be equal, convert the denominators to be equal, then we can write the rational numbers between any two rational numbers. Okay, next comes the concept of mean. The concept of mean we have already studied in our 7th standard. How it is? Mean is nothing but addition of two rational numbers divided by 2. Add addition of two rational numbers divided by 2. Now it implies if you take the we have to take the LCM for 1 and 4 and 2, you will get 4. So here 1 plus 2 times, so it is 1 into 2, and this 2 will become into 2 by 1. Alright, next step is 1 plus 1 into 2 is 2 by 4 into 2 by 1, which implies 1 plus 2 is 3 by 4 into 2 by 1. 2 1s, 2 2s, so we get the answer as 3 by 2. So the rational number between 1 by 4 and 1 by 2 is 3 by 2. This is using the mean method. So these are the two different methods wherein we use to find a rational numbers between two rational numbers.